So, based on what is on the board, what do you think we're going to be learning in this new chapter? That's right, chemical equations. Okay? So that should be the title of your notes for today, chemical equations.
Yeah.
We are not going to start on this page. We are going to end on this page. And I will warn you now, you're going to earn your freedom based on your ability to do what's on this page. Only if you succeed will you be free. We're going to go back to the beginning. In fact, we're going to go back to the beginning of chemistry. One of the first things I asked you was, why are we doing chem? In this last unit, it was pretty hard because you had to know like the number of valence electrons in order to be able to do the shapes, in order to be able to figure out what it's like Lewis dot diagram was to get its like dipoles. How many of your parents use dipoles in their like professional work? That's right, almost none of them. Why do you think we make you learn dipoles? No. What was your guess?
That's a good answer.
I would say no. There's a really low probability you're going to actually work with dipoles. Carlos? No. I could have not put that in the unit. No. This does not build on dipoles and things like that. We do dipoles for the same reason that people do push-ups. Why do people do push-ups? To get stronger. What part of your body is getting stronger by doing dipoles? Your brain. We don't know what you're going to have to do, but forcing yourself to learn things and to think hard and do like extended processes of like reasoning and comparison, all of this makes your brain better. That is the point of most of what we're doing. Whatever you're going to do, you're going to have to think. And you're going to have to like figure out hard problems and concentrate. And so you are learning those skills. It is not really about the dipoles. It's about analysis and concentration and perseverance. And that is what your brains are getting better at through this process. Just like you needed to know how many valence electrons oxygen has for the last unit, you're going to need to know the polyatomic ions for this unit. We did a quiz on them like 4 weeks ago. And most of you had them then. It's probably slipped out of your brain a little bit, and we're going to review it right now. So, raise your hand if you know the name and formula of one of the polyatomic ions. Carlos. Ammonium. What is the formula of ammonium? Shh, I'm listening to Carlos. Got anything? NH4 plus 1. If your hand didn't go up when I was like, can you tell me one of the polyatomic ions, you should definitely be writing this down if you don't know one of them. Okay? Hopefully you know all 6, because again, these are the building blocks that we're going to use in putting stuff together. Tell us another one, Liam.
Nitrate.
Nitrate. What was the formula for nitrate, dude?
NO3 minus.
Correct. NO3, and it gets a -1 charge. Somebody raise their hand and tell us another one. Sorry. Carbonate was? Good. CO3 -2 charge. Ava, who's going back in her notes to some previous day. What do you remember of the polyatomic ions?
Hydroxide.
Oh, you remember hydroxide. What's the formula for that?
OH.
Oh, it's OH negative. Great. Hydroxide, OH negative. Talk to me. Zara.
Phosphate.
It looks like kind of like you're reading, Zara.
I am.
You are reading. Okay, so rather than read, anybody remember? Let me hear if anybody remembers. Phosphate. Okay. Just based on what we saw for like nitrate and carbonate, what do you think phosphate is going to start with? A P. Okay, and then it's going to have a bunch of what's stuck to it?
Oh.
A bunch of O's. Zara, how many oxygens? How many oxygens? 4. And its charge, in this case, happens to be 3 minus. There is one more 8 out there. Not oxate. Sulfate. sulfate, I'm just going to change color for funsies here, is SO4 2-. It's getting a little cluttered there. These 6 chemicals, again, are pieces that we are going to use. Bricks in our wall. You need to know the bricks so you can build the wall. There is one other chemical that we're going to be using in this chapter, bonus chemical, ammonia, which is very similar to ammonium except the last few letters, but that makes a difference. Okay? This one is NH3. A little smaller than ammonium, and its chemical formula is a little shorter too. 3. So write this down, add this, and you have 7 chemicals that you're like, okay, Dave said ammonia, I know what that is. Dave said carbonate, I know what that is. You're going to need those pieces. 3, 2, 1. What are some gases that always come in packs of 2? A gas, when you think of that gas, it comes in what chemists call a diatomic setup. The gas you've ever heard of in your normal life that comes in packs of 2. Oxygen is correct. Oxygen, if you think about oxygen, you're like, oh yeah, I'm breathing O2, and you can sound like smart in middle school for knowing that fact. Okay, oxygen comes in a pack of 2. What else? Carbon dioxide has oxygen in a pack of 2 because the carbon, that's got a 3-atom molecule, so that's not one of the ones we are thinking about. Do you guys know what most of the air around you is made of? It's not oxygen, it's nitrogen. And nitrogen also comes in packs of 2. There's a whole family that's close to being satisfied, but always bonds to itself to get there. Any idea what family I'm discussing? The halogens. If you think about your halogens, if you have 2 fluorine atoms, each one of them starts with 7 valence electrons. Is it happy? No. And so if it finds another fluorine atom, they're going to bond to each other. And so fluorine comes in packs of 2, and chlorine, and bromine, and iodine. And there's one more. And it's okay if you guys don't know it yet, that's why they pay me. Okay? And that other gas is hydrogen. How many diatomic gases are there? 7. And that in itself is a helpful mnemonic device. A helpful memory device is to remember that there are 7 diatomic gases. Because what is element number 7 on the periodic table? Nitrogen. And if you look at nitrogen, that's one of my diatomic gases. And if you start at nitrogen and make a 7, ta-da! Those are the other diatomic gases. Nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. However, when I make that 7 on the periodic table, how many gases do I include? 6. What's missing? 1. 1 is missing, and what is 1? It is hydrogen. So that's a way of remembering it, that there are 7 of them, and that they make a 7 on the periodic table. The other way to help you remember it is to remember the scientist that first came up with this. It was a German gentleman by the name of Professor Hinkelbroth. Write down Hinkelbroth. Say the word Hinkelbroth. Let's try it one more time. Hinkelbroth. Let's see it. Hinkelbroth. Okay, so Professor Hinkelbroth is not a real person, but it's just another way of remembering hydrogen, iodine, nitrogen, chlorine, bromine, oxygen, and fluorine. Hinkelbroth are these 7 diatomic gases, not a real German professor. It would be pretty cool. So, as you're writing chemical expressions, which should be the title at the top of your notes, we're now ready to sort of dive into the new things, writing these equations. Okay? We're going to write things. We're going to have a before, we have an arrow, and we're going to have an after. Carlos, if you want to close the window, it's up to you. The noise versus the heat, it's your choice. So, with our before and after, we're going to separate them by an arrow. Does everyone know what the stuff that goes into a chemical reaction is called? No. We'll get to energy in the months. Okay. Say again. That's right. The before stuff are the reactants. The after stuff that is produced in the chemical reaction are called the products. One of my great-great-grandmothers was killed by a bunch of vowels, so I'll often abbreviate these things without vowels in them and just make it like reactants or products, or sometimes just R and P if I'm working quickly. Okay? So you should just know that like reactants means reactants. Smile and nod. There. And this is the kind of thing you're going to have to do. I'm going to give you a bunch of words. Go ahead and write these words down in your notebook. Go. Write all these words down in your notebook. The fastest of you are getting this done in about 30 to 35 seconds. Some of you are still writing. It takes a while to write all this stuff out in Word. We are looking for a quicker and more convenient way of doing so. What can I write instead of writing out nitrogen gas? N2. What am I going to write instead of and? Nope. Instead of and. Plus. Instead of hydrogen gas. H2. And that's why you need to know that it comes in diatomic packages so you don't write H, you write H2. Okay? Mate. What am I going to write instead of the word mate? An arrow. What am I going to write instead of ammonia liquid? NH3 is a new compound that we met today. Okay? That takes less than 10 seconds to write compared to 30, 35 seconds to write out all the words. It is a convenient, condensed way of conveying that information. However, states of matter matter. It matters what state of matter it is in. So we are going to include that information as well. If something is a gas, we are going to put a little parentheses G as a subscript after it. So too with the hydrogen here. It's going to get a little G. The ammonia, what do you think I'm going to put after that? A little subscript L. There are two more states of matter. One of them is easy, that's solid. Okay. The other one is not plasma. A lot of people are like, oh, I know the fourth state of matter. We're not going to like build a solar furnace in here. We're not going to create any plasma and do any reactions. Instead, we are often going to dissolve chemicals in water. Because that's a good way to get them to mix with each other is you put them both in water first, the ionic things dissolve, and then you pour them together to react with each other. So if you dissolve things in water, it's called an aqueous solution. And we're going to abbreviate that AQ. If you don't know otherwise, you can guess it's going to be aqueous in here in the next month. We do a lot of aqueous stuff. That's AQ. Sorry. Good. Concern. AQ. Aqueous. Aquatic. 3, 2, 1. Oops. Wrong page. Talk to the person next to you and try and write a chemical formula for aluminum metal reacts with chlorine gas to produce aluminum chloride powder. Go. If you want to write it out first, I wouldn't bother. Hopefully, just get it off the board. It's up to you. Okay, just try and write it out. am I gonna write for aluminum metal? Al parentheses S. If it's metal, it's probably solid. That's a reasonable guess. Okay. Amelia, what else am I gonna write? Correct. Chlorine coming in gaseous form, being diatomic because it's part of Hinkle broth. Okay. Gemma, what else am I gonna write here? And then and the 2 is a good question, a good thing to pause over here. Jackie, it seems irrelevant, but I'm gonna ask you what the charge on sodium is. What is the charge on sodium based on our friend, the periodic table? Guess again. +1. Okay. Alice, what is the charge on magnesium? Ava, what is the charge that aluminum is likely to get based on its position on the periodic table? +3. So if aluminum gets a +3 charge, and chlorine, Zach, gets what kind of charge based on its position on the periodic table? -1. It needs to gain 1 electron, -5 points per grade for the year. Just kidding, it's okay to make mistakes. Trace, what formula is this going to be if I like procedure X this puppy? How many chlorines do I need to balance off that aluminum? 3. So this is going to be AlCl3. And that, my friends, is going to be some of the hardest stuff you are going to have to deal with in this chapter, is putting the compounds together correctly. And this is stuff that we learned like a month ago when we did ionic compounds, going back to the periodic table of it and being like, oh yeah, these are -1, these are -2, these are -3, maybe -4, +1, +2, +3, generally +2, and then procedure Xing that stuff to put the compounds together. Trace. Because we are not learning to balance it today, because what we have to do today is enough. We will come back tomorrow and we will work on balancing off between the two sides. It's a good thing to be like, oh, that seems wrong. It is wrong. We're not done yet. We're just building one piece of the foundation today. Carlos. So again, oh, and the S. Thank you. That'll be solved. Oh, this is a solid because we said it was a piece of metal, so it's probably in solid form. Oakley dokley. That's ionic stuff. You also need to remember how to write covalent stuff. Go. Liam, what is tricarbon octahydride going to be? What am I going to write for that? C3H8 is correct. What form of matter do you think propane's in? Gas. We've maybe heard of that culturally. Propane is a gas. Carlos, what am I going to write for oxygen gas? O comes in what kind of packets? 2. O2, and that's going to be a solid, liquid, or gas? Nope, oxygen's a gas, dude. Okay, makes. These two are chemicals you've heard of before. Josiah, what's my first one? Cole, what's my second one? Okay, and the CO2 was a gas, and the H2O was a liquid. Smile and nod. Pretty doable when it's covalent. What is a name for this type of reaction? The name for this type of reaction is bubbles. Just kidding. Okay, here is some propane gas in my hand. Okay, this is a fire reaction. Okay, hydrocarbon plus oxygen making carbon dioxide and water. That is a combustion type reaction. And because the place class a little dry, I'm tossing things in there just to thank you very much. There are other demos that are going to happen today. Right now, go ahead and try this a little bit more challenging ionic compound setup. Remember, that the Roman numeral tells you the charge on the metal. The Roman numeral tells you the charge on the metal. Talk to your person next to you. Share, work, think, grow. Yes. It's right there. This is the hard part of this chapter, is getting the compound straight. Oh, yes. Rosalind, what is silver's charge in this situation? +1. Noah, what is iodine's charge based on our friend, the periodic table? Nope. Iodine is a halogen. What charge do halogens get? -1. Iodine is a halogen, they get a -1. So if I put those together, LC, if I put these two chemicals together, what is the formula for silver 1 iodide going to be? It would just be AgF. This one's giving away 1 electron, this one's taking 1 electron. So that's just going to be AgF. In this case over here, I've got my iron 3 carbonate. So, talk to me, Isabel. Iron, what's its charge going to be? +3. Metal tends to get a positive charge. Jaden, what is the formula for carbonate that we reviewed at the beginning of class today? And so you get one of the hardest questions of the day, Lauren. What is the formula for iron 3 carbonate going to be if we procedure X that puppy? Fe2. parentheses 3. Good job. Okay. That is not trivia. That is like the hardest thing we're going to do in the ionic compound thing. This goes outside of the number of carbonates. I have 3 carbonates and 2 irons in that puppy. Non, maybe. This is what we're going to be practicing. Getting that back. Okay. Now we've got silver carbonate and iron 3 iodide. I'll do iron 3 iodide. Iron is +3. We've already discussed that iodine is -1. So Jasmine, what's the formula for iron 3 iodide going to be? I got these 2 things coming together. I want to procedure X them. Smart Fork is better. Okay. If I want to procedure X them, what is that going to then be? Fe, I3 is correct. Okay. Now I have the silver carbonate. I want you to change pen color. I have to do my finger instead. All right. The silver carbonate. Eli, the silver is +1. The carbonate is -2. So the formula for that thing is going to be that's why I asked it. Hey, I'm going to take the number and move it down and make it the subscript there. So this 2 is going to be here. Ag2. And then this is a +1, so I'm just going to have 1 carbonate group. Ag2CO3. There. Yes. That is the thing you have to do. Arg. Go. Look at Liam's notes. Liam, you got the notes? Show him what Liam's notes. Okay, good.
I just did a C backwards. This is what class needs to do.
I should have put AQ after all of them. My bad. That's not what I find to be the hard part, so I don't focus on it like I should. No, let's not focus on that. They're all aqueous, but the hard part here is the ionic structure, not the solid.
So it'd be lithium 2, and then that would
French.
So that would make it CnCO. It would be CN2, CO, and then and lithium sulfate would be Li.
You take the charge, put on the other one's charge is the superscript. They never bond with each other. Sulfate bonds to zinc, carbonate bonds to lithium. Zach and Ava, you guys agree with what you have written down so far? I don't know. Well, let's talk. That's why we have people in our lives to talk to them. Work with them. Teddy Rocky. Zinc here has a +2. What is the formula for sulfate, sir? That's right. Sulfate is SO4. And the charge does it get?
I thought it was like
-2. So when you put those together, Amelia, what do you have as the formula for zinc sulfate? No. Just ZnSO4. Because if this is giving away 2 electrons and this one is taking 2 electrons, it's just going to be 1-to-1. So that's just going to be ZnSO4. Ellen, how about you stay here and sit with Trace or Zach to just hear this a little bit since you missed this morning. Okay. Gemma, lithium, based on its position on our friend the periodic table. What charge does lithium get? Not -1, +1. Okay. Carbonate that we wrote down there, Jackie, is just this is a little Dave Souls pet peeve. Say CO3 -2. So you say like CO -2, the 3 is like awkwardly floating out there in conceptual space. It's CO3, 1 carbon, 3 oxygens, and it gets a -2 charge. Or 2 minus, doesn't matter, I have to already write this. So I'm putting that together, Alice. Lithium +1 and carbonate -2. What is the formula for that puppy going to be? Yep. Correct. Li2CO3. Smiling? Smiling? Nodding? Not really. Okay, it's again, because I have a 2 here, that 2 becomes down here. This is a 1, and so that 1 comes down there. I have 1 carbonate and 2 lithiums. The superscript on this becomes the subscript on that. Ava. I have zinc carbonate. Okay. Zinc carbonate. Zn is +2. Carbonate is -2. What's the formula for that going to be? Just ZnCO3. Okay. The +2 and the -2 cancel each other out. This one's giving away 2 electrons. This one's taking 2 electrons. That works out nicely. And lastly, lithium sulfate. Zach, what's the charge on lithium? +1. Sulfate is -2. Noah, talk to me. What's the formula for lithium sulfate going to be? Not quite. LiSO4. The sulfate needs to gain 2 electrons. Each lithium only gives away 1, so I'm going to need 2 of what chemical in that thing? Which of these am I going to need 2 of? I need 2 sulfates or 2 lithiums to make this neutral. 2 lithiums. Li2SO4. That's the work.